In this lesson, we're going to talk about solving two-step equations. Solving equations involves inverse operations. As you previously learned, inverse operations is a fancy term for applying the opposite action. Addition is the inverse of what operation? Subtraction. So if we take a look at this problem, x minus 5 equals 7. So we know that we have x that we're trying to isolate, and on this side of the equal sign, we're subtracting 5. To cancel it, we need to apply the inverse operation of addition of 5. That's going to equal 0, which is how we cancel it out. But as we know in equations, to keep things balanced, whatever we do to one side, we have to do to the other side. So we also add 5 to 7 and get 12. That means our final answer is x equals 12. So when we have subtraction, our inverse operation is addition. Subtraction is the inverse of addition. So likewise, when we're trying to isolate a variable, if I see something being added, I'm going to subtract in order to cancel it. Positive 3 minus 3 is 0. Whatever I do to one side of the equation, I must do to the other side. 12 minus 3 is 9, and so we know we end up with x equals 9. So when we had addition, we applied the inverse operation of subtraction to isolate the variable and find our solution. Multiplication is the inverse of what operation? Division. And so when we have a problem that has division, we are going to multiply. We know this is division because it's got a fraction bar. The 2 is in the denominator, which means divide. So we're going to multiply by 2, which will cancel. And whatever we do to one side, we must do to the other side. And we get a final answer of x equals negative 10. Again, applying the inverse operation of multiplication when we saw division. Division is the inverse of multiplication. So in a problem where I have multiplication, notice how the 3 and the x are touching, which implies multiplication. So my inverse operation is division. Again, I'm going to do a fraction bar. A 3 in the denominator means I'm dividing. These will cancel to make x equals whatever I do to one side, I must do to the other side. And so I get 15 divided by 3, which is 5. So we know that solving equations involves inverse operations so that we can undo the action that is being applied to the variable. Addition is the inverse of subtraction. Subtraction is the inverse of addition. Multiplication is the inverse of division, and division is the inverse of multiplication. So the question becomes, what do we do when we have two operations in one equation? Because we know what to do when we see one operation, how do we know what to do when we see more than one operation? Well, the answer is we're going to follow the reverse order of operations. Order of operations you may know as PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. And normally you work the problem following the order of operations. But when we're solving, we are going to go in the reverse order of operations, which looks like SADMAP, which is also kind of a fun word to say. In reverse order of operations, we're going to focus on subtracting or adding first. So if I have x minus a number or x plus a number, that's going to be the first operation that I apply the inverse. Next, we're going to look at anything that's being divided or multiplied. So if I have a number in the denominator dividing, or if I have a number touching the variable multiplying, that's going to be the second operation that I handle. We will talk about exponents and parentheses later on, but just so you know, they are still a part of the process of reverse order of operations. So let's take a look at our first example. Our first step in solving is always to put a line down the equal sign so we know both the sides that we're working on, and we're isolating our variable. So I like to circle it so I know what I'm working with. Now, if you remember, in reverse order of operations, we have SAD, SA, MEPS. So the first one that we're going to look at is anything that's being subtracted or added. So we see here that we have plus 3 that's happening to the variable x. So I'm going to apply the inverse operation. What is the inverse operation in this problem for what is being added? Subtracting 3. Remember, whatever I do to one side, I'm going to have to do to the other side. I'm going to go ahead and simplify my work. 15 minus 3 gives me 12. Drop my equal sign, which stays on the line. This cancels, which is what we wanted, and we're going to drop down the term we didn't use, which in this case is a 4x. I know I still have more work to do because I don't have my variable isolated. So you know you're done solving when x is all by itself. So again, line down the equal sign. This 4 is touching the x. I know that when terms are touching like this, it implies multiplication. The inverse operation of multiplication is division. So I'm going to go ahead and divide by 4. This is going to cancel to 1, and I'm going to get 1x equals 12 divided by 4, which is 3. And that is our final answer. One cool part with solving equations is you can actually always check your answer. So my original problem was 4x plus 3 equals 15. So I said x equals 3. So I can go ahead and take this, and I can substitute in 3 anywhere that I have an x. And then I continue to do the math to check my work. 4 times 3 is 12 plus 3. And when I simplify that step, I get 15 equals 15, which is true. That means that my answer is correct. So it's kind of nice. We have a built-in checker. Go ahead and try this next example too and see what you get as your answer. So if we take a look here, my first step is always to put a line down the equal sign and circle by variable so I know what I'm solving for. So we are going to first move anything that's being added or subtracted. So we have plus 10. So we're going to do the inverse operation of subtraction on both sides of the equation. And that's going to give us 65 equals, we know this cancels, and we drop down our first term of negative 5x. Continuing the problem, the next step, we're going to get rid of what's being multiplied by the inverse operation of division. What we do to one side, we must do to the other side. These cancel to give us x equals a positive divided by a negative is a negative. 65 divided by 5 is 13. So our final answer is x equals 13. What can we do to check our answer? To check our answer, we're going to go ahead and evaluate the equation where we plug in negative 13, our answer, for anywhere that we had x. And of course, when we check out this work, a negative and a negative multiply to a positive. 5 times 13 is positive 65, plus 10 equals 75. And we know 65 plus 10 is 75, which is in fact 75. So our answer is correct. Again, don't forget you have a built-in checker, which is pretty awesome when it comes to math. What operation do you think we will do first when solving example 3? Hopefully you saw that the first step is to draw your line down the equal sign, isolate your variable, and we have a subtracting 3. Remember that reverse order of operations, we're always going to start with what's being subtracted or added first, and then what's being divided or multiplied. So in this case, we're going to add 3 to both sides of our equation. Simplifying our work, we get 10 equals, these cancel, and we drop down our first term of x divided by 4. What operation are we going to do next? We have a 4 in the denominator, which means it's dividing. Our inverse operation is to multiply. What we do to one side of the equation, we must do to the other side. These cancel. We're left with x equals 40. Keep in mind, when you have your variable all by itself, that's how you know that you've finished solving for your solution. We can check our work by plugging in 40 for x and knowing that we do get 7 equals 7, which means our answer is correct. Go ahead and try your best on example 4. So our first step in example 4, we're going to subtract the 9 from both sides. Notice I forgot I should always start with writing my line down my equal sign and circling my variable. That's a great step for organizing your work. Simplifying what I have, -4 minus 9. Remember, that's where we're going to be combining to become more negative. We get -13. This cancels, and we drop down our first term, x divided by -3. Our next operation is to multiply by -3, since that's the inverse of division. What we do to one side, we must do to the other side. X equals, notice, I just made a common mistake. When you're rewriting, the sign matters. So when you rewrite it, you want to make sure you have that sign in there. Always, always good to check your signs, to check yourself before you wreck yourself. Negative times a negative gives me that positive. 13 times 3 is 39. So our final answer. Don't forget, you can check your work by plugging in 39 for x, evaluating it, and you get -4 equals -4, which is how we know we have the correct answer. Think for a second. What is the difference with example 5? Look at example 4. What is the difference between this example and the previous example? Hopefully what you noticed is that our denominator of 4 is going over the entire term x plus 3. So where this happens, we actually need to take care of this 4 term first. So even though we would normally do what's being added or subtracted, because everything is up top, it's actually like it has parentheses around it. So we have to get rid of that 4 before we can do anything else in this problem. And that's going to cancel here. We're going to get our entire numerator, which was x plus 3, equals 28. Go ahead and finish solving this problem. We're going to get -3 on both sides. Again, always recommend you write the line down the equal sign, circle your variable. We're going to get x equals 25. Keep in mind, you can still check your work the same way by plugging in for the variable. This one is a little bit different because of how it's written. But notice that it's still going to be the same process of putting in our answer for our variable. We're actually going to evaluate this numerator first. 25 plus 3 is 28. Divided by 4 is 7. When we get 7 equals 7, we know we have a correct answer because we are awesome mathletes. Example 6. What is different with this example? Hopefully what you noticed is that we have an entire fraction being multiplied by our variable. So we're going to talk about how to get rid of this fraction, but what do you think the first step is? Our first step is to subtract 2 on both sides of the equal sign. This is still a case where we're going to do reverse order of operations, good old SADMEPS. And we're still going to do what's being subtracted or added because this 2 is not being divided by anything. So we don't have to put them all together. We just focus on what's being subtracted or added first. Simplify our problem. Drop down our first term equals 15. Now, if you remember from last lesson, we know how to get rid of fractions by using what's known as the reciprocal. Reciprocal is going to be the flip. So I have my 3 on top. Notice how that would be the inverse to cancel the 3. But I also have my 5 on bottom because that's going to be the opposite of my 5 being multiplied by x. So that's how I'm going to cancel both of those terms to isolate my variable. But what I do to one side, I must do to the other side. Now what might help you is realizing that 15 is actually 15 over 1. Any number can be made into a fraction by putting it over 1. Because think about it. What's 15 divided by 1? 15. So I'm not actually changing the number, but sometimes making both numbers as fractions can make it easier to see what you're supposed to do next. So we're going to go ahead and do 15 times 3, which is 45, divided by 1 times 5, which is 5. I'm not quite finished yet. My last step is to simplify 45 divided by 5 to know that my final answer is 9. Don't forget, you can always check your work by plugging in 9 for x, and then we're going to simplify. We're going to make 9 over 1, because again, sometimes when you're dealing with fractions, it's nice to have all the numbers be fractions. 5 times 9 is 45. 3 over 1 is 3. Divide that, and you're going to get 15 plus 2, which is 17, which means our answer is correct. If you've completed this lesson for the notes, go ahead and complete the practice problems to check your understanding. Thanks for being so awesome.